Quick advert for Siemens. We do everything. Move on. We cover the entire renewable and conventional energy value chain and do grid and metering as well. But there's a stand outside where Andy will happily tell you far more about what we do. Offshore wind. Somebody recently told me that only about 10% of the countries in the world have a really exploitable offshore wind resource. So from an economic perspective, you might see it as a fairly marginal technology, perhaps a curiosity on a global basis. But one look at the map on the left-hand side there, for the UK, it's actually the main game that we have in town. If we look to the future, when we've got a supergrid connecting all of Europe, and we've got a totally decarbonised electricity supply, just from a balance of payments point of view, and with great respect to the next speaker, we're probably not going to do as well in the solar stakes as some of the southern European countries. But what we have in abundance is shallow water and wind, and a bit of tidal and wave as well. And so the UK really needs to exploit the resource that it has. And that's why the UK at the moment has certainly Europe's largest offshore wind programme in the planning stage. But just look at some of the numbers there. This was done, a group called the Offshore Valuation Group did some work last year. And they said, well, if we just exploited a third of the straightforwardly exploitable resource and allowing for shipping lanes and fisheries and all the rest of it, but just a third of what was left, we could still have an industry that was producing the equivalent in energy terms of North Sea oil and gas at its peak and create 145,000 new jobs in the UK. So it's big business. And here are the UK's plans. If you're not familiar with the offshore wind programme, there are, perhaps I should have said, there are reasons for going offshore. Two main reasons. One, members of the public can't see it. So offshore wind is a kind of an expensive way of getting around planning issues for onshore wind. But secondly, the wind regime offshore is actually better in that the wind blows more consistently offshore. You get a higher load factor, which, as we've heard today, some of the variability of wind is reduced when you start looking at offshore wind, particularly when you look at offshore wind over a large geographic area. The seabed is owned on behalf of the Queen now. It used to be on your and my behalf, but the Queen did a great deal replacing the civil list with income from the Crown Estates, just as the Crown Estates is about to spend £150 billion on creating a whole new infrastructure offshore that will be renting the seabed at quite a few pounds per megawatt hour. But the Crown Estates license areas around the country. Little red dots here that you'll see blink and reappear are round one. And those wind farms are the ones that you might see around the coast at the moment. They're a few kilometres offshore, typically 90 megawatts, fairly experimental. But before we've even built those, we've moved on to round two, which are larger. And here we're talking about wind farms up to, say, 500 megawatts, similar to Greater Gabbard, or 300 at Thanet was mentioned earlier today. Scotland has its own inshore waters programme, but the big one is round three. And you can see the areas for offshore wind there are considerably larger. And if we build all of that, we will have 50,000 megawatts of offshore wind capacity in this country. The maximum demand of this country is about 60 to 65,000 megawatts. So on a windy day, we could supply just about the whole demand of the country from offshore wind, if that gets built. And how much of it is built so far? 1.5 gigawatts built so far, over 2 gigawatts under construction, and another 1.5 consented. But that really is the tip of the iceberg. If you look at what's actually signed up to grid connections with National Grid, there's a further 26 gigawatts that's now signed up to grid connections. So this is, if you're familiar with the wind industry as it was just even a couple of years ago, be aware this has moved into a different kind of scale. Now, it won't be built as fast as that, and maybe not all of it will be built, but this is a sizable industry. So what goes to make up a wind farm? Obviously there's a wind turbine, but the wind turbine itself is maybe 40 to 45% of the capital cost of the wind farm. It sits on a foundation, which, depending how deep the water is, might be another 20%. Now, it's a combination in both of those of the actual asset itself and the getting it there and the looking after it. At the base of each wind turbine, we have a switch to connect it to a medium voltage array of collector cables, which then come together at an offshore collector substation where we boost the voltage and send it to the shore through a higher voltage cable. And as we go further offshore, we will move to DC, which is a different technology. You have a conversion loss at each end, but then a lower loss over the distance, and that becomes more efficient at around about 70 kilometres. At the onshore end, we need to make the AC wind farm look like a conventional power station to meet grid code requirements, and that's where we build some reactive compensation and some other things. And the company I work for does those things. Let's just click on. Offshore wind is all about logistics, and we're learning a lot. We're very much in the early pioneering days of this technology at the moment, and there's tremendous opportunity, therefore, for the cost to come down as we get some tools and some processes that are better for the job. That photograph was taken at Thanet Offshore Wind Farm on the day that this is the Stanislas Uding. That crane is lifting into place the offshore substation. That offshore substation is just under 2,000 tonnes, and it lifted it in one go. You can see over here, that's the resolution with several kits of parts for wind turbines. It's a jack-up barge, so its legs go down to the seabed, it rises up out of the water, and a big crane can then install wind turbines. And these are the sort of big bits of kit that we play with. So you can see on the top left there, that's another jack-up barge building a wind turbine. Top right is, that's the Greater Gabbard offshore substation being floated out of Tyneside. On the left there, that's either Gabbard or Thanet being lifted into place. The one in the middle is a device for laying the inter-array cables. These are the medium voltage cables that go between the wind turbines. And the one on the right there is at near to Sizewell Nuclear Power Station, Leiston in Suffolk. That is the reactive compensation and grid connection substation for the Greater Gabbard offshore wind farm. So it's big engineering stuff. Similar kind of investment profile really to the nuclear industry that we were hearing earlier today. Well, we're talking about massively ramping up an industry that didn't used to exist over a short number of years, and that is bound to lead to questions about, is there a supply chain for it? And more importantly, where will that supply chain be based? If you look at the wind turbines themselves, I don't think they will be a bottleneck. That picture is the factory that Siemens is planning to build in Hull to manufacture the next generation of wind turbines, and that was announced at the start of this year and will be on stream about 2015 and sort of up to full production 2016-17, depending on the state of the market. You may have read in the press that wind turbines depend on a few things that might or might not cause a problem. The pile of metal there are rare earth metals. At the moment, the main supplier of those is China, and China decided that it would exploit its monopoly position about a year ago, since when several mines in North America have reopened. And actually, I don't think that that will be a constraint on the industry. And certainly the Chinese are quite embarrassed and want to put right some of the stories they've had about the sort of the working conditions and the environmental situation around producing that material. So I think over a period of time that will get less important. Jack-up vessels, there are a limited number of those at the moment, but that one there is a picture of a new vessel that we're commissioning. That will be built in about a year and a half's time. Each one of those vessels is maybe a £200 million investment. But it's, if you've got a project or a series of projects to work on, you can build one of those in less than 2 years, and there are several people who have plans for boats, and the moment that they can see the market, those boats will get built. Last one on the bottom right-hand side, that is the hub of a 3.6 megawatt wind turbine. That is the largest dynamically loaded single cast piece that I'm aware of anywhere in the world. There may well be some military application that uses big pieces of metal like that, but certainly there are very few large castings that have to go round 150 million times over 25 years of that sort of size. Casting something like that takes a week to cool down. And there's a tremendous opportunity, and we were talking just briefly at the break. You want to be doing that local to your factory. So if we're building a factory in Hull, we'd love to be making those in the UK if the UK can just work out how not to tax out of existence forging and casting in this country. So if we start to think of jobs and carbon reduction in the round and look at the whole carbon footprint of things, I'm sure we can make a case for why actually we should be heating up bits of metal in this country in order to make things, to make electricity that doesn't create carbon dioxide. So conclusion to that part is that the wind turbines themselves are probably not going to be a bottleneck. 3 manufacturers have announced that they want to build factories in the UK, all of them with the caveat subject to the market. Where else might the bottlenecks be? It's in the rest of this picture here, maybe. But if we look at the offshore substations, my background is working for the grid connection side of Siemens, and so these are all my babies over the last few years. But we've built 8 of these offshore substations in the last 2.5 to 3 years. So if you average it out, 3 a year, we're already doing. Well, even at the peak of round 3, we're not anticipating more than about a dozen a year being required. So if we just double our capacity, which we're already planning to do in Manchester, we could do half of them. So I don't think there'll be a supply chain bottleneck in the first-tier suppliers of the grid connections either. It will, however, mean that we are using every single fabrication yard around the coast of this country. And that also relies on doing the foundations for the wind turbines somewhere else, so not in the same fabrication yards that are building these. Now, that's a reasonable assumption because at the moment, if you wanted to build a one-off foundation for a wind turbine, you'd go to a fabricator. But if you're trying to do 200 of them, you need to create a new purpose-built facility and industrialise the process, and that's what we're looking to do as an industry. I think the bit that's probably closest to being a bottleneck is the submarine cable. There are 3 manufacturers in Europe that make submarine cable of the right voltage for the big export cable, and a small number more who make the lower voltage cables. One of those cable factories can produce about 200 kilometres a year. We can tie up a whole factory just building the Hornsea project, which I'll tell you about in a minute. There is an urgent need to create new cable manufacturing capacity in Europe. And to have that ready in time to build the round 3 projects, which were going to be in the water by 2016, 2017, the investment decisions need to be made this year. Just at the moment when there's complete uncertainty during energy market review. So whilst energy market review will be resolved in time for the final investment decisions for the project developers, we in the supply chain have to make our decisions now, and they're big one-off binary decisions. Do we build a wind turbine factory? Do we build a cable factory? And we've got to make them against complete uncertainty as to what the future regime is going to be. So we are extremely interested in what comes out in about 4 or 5 weeks' time from the government in terms of the summer white paper and particularly the roadmap. People, definitely a scarce resource. We're creating a complete new industry. It has similarities with the electricity industry. It has similarities with offshore oil and gas. It has similarities with marine contracting and other things. But it's actually a completely new synthesis of all of those. I'm standing in front of you, so I'm claiming to be an expert in this industry. I've only been doing it for 7 years, but actually a lot of people have only been doing it for 6 months. Particularly a lot of the investors I meet If they've been in the job for more than 9 months, then they really are an old hand. There are a lot of charlatans in this business, and I'm one of them. So don't take everything that I say completely as gospel. But it's very easy in a new world to be confident of your own domain knowledge and to accidentally step into a slightly different area that you're no longer expert in, but still keep pretending that you are. And there's too much of that in the offshore wind industry at the moment. What will it all cost? I'm sure you've been thinking that. At the moment, the levelised energy cost, depending which study you look at, the number that people seem to cling to is about £147 per megawatt hour, which is too much. That is not going to lead to an industry that we can sustain. The subsidy required to do that is just too much. And I don't think electricity customers, whether they be major users or domestic users, will allow their politicians to pay that much subsidy. How much will it be in the future? Well, the target for the industry has to be bring the cost of offshore wind down so it's comparable or ideally better than fossil fuel. And that's a challenge that I think is very, very doable. Bearing in mind what I said, that we're right at the start of an industry, lots of ways of bringing the cost down. The other thing to say is that who knows what the price of the fossil fuel is going to be going forward. If you are designing and building an offshore wind farm, as with a nuclear power station, it's about making your business decision up front, and on the day you make that decision, within a pretty small margin around some risks, you know what your price of energy is going to be for the next, well, the lifetime of the project. Whereas with fuel, the graph on the right there are some DEC estimates of the price of coal, but there are similar graphs for gas and other things. You can see historically it bobs up and down at a rate of knots, and their assumptions for the future, high, medium and low, are sort of have a variance of about 100%. So nobody quite knows what the cost of fossil fuel is going to be, but we think if we take roughly a third out of the cost of offshore wind, that will make us pretty competitive. And I like the slide that was shown before the break. I'm less keen on these numbers that came out from the Committee on Climate Change a week or two ago, mainly because they assumed that the cost of offshore wind is not coming down, and I think that's partly because they didn't come and ask people who make it. There are lots of ways to reduce the cost. I'm running out of time, so I'll just flip through these and say it all depends on having a pipeline of work. And I'll show you what a healthy industry would look like from my perspective. The red bubbles at the top are the list of projects that are out there to be done, and you'll see round 3 main sequence starts 2017 and onwards. That's when these really big projects start getting energised. In order to be doing those in a more cost-effective way, we need new factories making new wind turbines to come on stream then. And again, the investment decisions for those factories are this year. But we already know that our new design of 6 megawatt wind turbine weighs a third less per megawatt than its predecessor. It's got about 50% of the components. That both reduces the cost of the generator itself, but it greatly reduces the cost of the foundation that it stands on. But even if we sold the wind turbines for free at the dockside, we've got the balance of plant to worry about. But there's tremendous opportunities there with new vessels and industrialising the process to take cost out. But the cost won't come down straight away. It'll start with the early projects with a bit of learning by doing. The lessons from that come into a bit more standardisation, and the first of the new vessels arrive. But really the cost reduction kicks in when we get to round 3, when investment decisions we're making now, and there's a theme here, start to bite. And that's the conversation that we're having with the government at the moment. It's about how much of this do you need to do to bring the cost down to minimise the cumulative total subsidy over a period of time and achieve the objective of decarbonising the UK energy supply, bring the jobs that we can export and the technology at the minimum total cost. Just to look at financing these things, there are 3 phases to the finance. There's a long planning and development process that doesn't cost too much money. Somebody does that on a balance sheet. You get your consent and you reach your final investment decision, and then you bring in a lot of money. A lot of money. The climate change capital entire budget would pay for about 15% of one 500 megawatt wind farm. So we're talking a lot of money. That's the real reason why we build in 500 megawatt blocks. It's not to do with any technological constraint. It's just to raise the £1.5 billion that you need to do that at the moment. You need a club of 10 banks. 10 banks will each have 2 lawyers, and the meeting room size becomes the limiting factor. Construction takes 3 years, at the end of which you have an asset, the construction risk is gone, and you can refinance and sell it to a pension fund. So, just to make the maths easy, if we said 3.7 gigawatts a year at £2.70 per watt is £10 billion per year. If you recycle that finance after 3 years, we need to raise £30 billion worth of construction finance from the markets to have this industry get up and running. That's not trivial. The balance sheets of the utilities can do about 2 gigawatts when they're all fully leveraged. We've got to get more money from elsewhere. And don't forget the supply chain needs some investment as well. So just to conclude on my talk, and then I'll get on to Steve's in a moment. Round 3 is big, but actually it really is definitely deliverable. And there are plans in place and there are investments that are being made to be able to do that. A steady ramp up rather than a huge spike and a drop off afterwards would help all of us in the supply chain. I don't think first tier suppliers will be the bottleneck, but the 1 or 2 niche things that we do still need to sort out. If you haven't seen anyone announce a new cable factory by the end of this year, well, actually, we probably are going to delay. That's the sort of lead time we're talking about. But the government is on the case, and there are many working groups, and I'm on some of them, looking at how we do this together, because the prize for the UK is absolutely enormous. It's a homegrown, world-leading industry that can export elsewhere, and it's a balance of payments thing. The renewable that we've got, the resource, we can share with the rest of Europe, and I'll talk about supergrid another time.